Good morning, everyone. How's everyone doing? You guys have to take a test? Huh. Well, good luck with that. If our it seems our attendance is steadily going down day by day. So obviously we're down to about just roughly 50%, maybe even under that right now. So you can direct people to the YouTube for all the videos that we've done in our class since we've been doing it remotely. Yes, there is sound. I put this page up. This is what we'll be doing for at least the first, I don't know, 5-10 minutes. And then I have a Regents question that we're going to practice. I mentioned it yesterday. You guys do not have it, so you'll just do it on the graph paper. So that's kind of our plan for today. We'll do the mid-segment of the trapezoid. We'll do a practice proof, and this proof came right off of the June Regents, and it is directly related to pretty much the two things we've been doing. There's coordinate geometry proofs that we did a lot last week, and then it ties in the trapezoid. And I mentioned they don't really mention trapezoids with coordinate geometry, but that is what we will that's what we will practice today. That way we can see a Regents question. So we'll get right into it. Most people are doing global currently. Ugh. All I ask is for 40 minutes. Hopefully our attendance is better later in the week. Because I think everyone should be here. I think we had everyone here on that first day. But we've been slowly diminishing. Hopefully this is not the trend. Alright, let's take a look. We're going to be doing the mid-segment of the trapezoid. And we've talked about mid-segments before. Mid-segments it's going to mean the same thing as they did with triangles. A mid-segment is when we connect midpoints, which does say that right here. It's connection of midpoints. So technically, mid-segments do not need to be contained within triangles. We did discuss them with triangles a little bit more deeply when we connect midpoints. So I'm going to write that over here, connecting midpoints. For what a mid-segment is. It's the same packet as yesterday. It's a steep downhill slope from here. That means it's a negative slope. That's not good. So right here we have the mid-segment, which is segment EF. This is the mid-segment to the trapezoid. And because it is a connecting midpoints, you have everything marked that is congruent to each other already. And we get two things that occur here that we can figure out when they are connected. One of them is pretty simple. It's actually identical to the triangle one. It's going to be parallel to the other two sides, which are already parallel, so AB and DC. So one of the conclusions we can make is that AB is parallel to EF, the mid-segment, which is also parallel to that third side because it's a trapezoid. So now you have all three which are parallel to each other. And because they're all parallel, you do get sets of corresponding angles and stuff like that. So you have these sets of corresponding angles which are congruent. You have these sets of corresponding angles which are congruent, as well as all the properties we talked about yesterday. Adjacent sides are going to be supplementary and stuff like that. So all those properties are still being followed. And the next rule, which is probably going to be a little bit more relevant, the one we're going to look a little bit more deeply into, is we could actually figure out the length of this midsegment if we know AB and DC, which is the midsegment EF is going to be equal to, we're going to add up the length to AB and DC. I'm going to put it in the numerator because it is going to be a fraction. So it's AB plus DC divided by 2, which is almost identical to how every other midpoint we have ever found looks like. Add two things together, divide by 2. It's the same as kind of like a midpoint, which makes sense. This makes it an average between the long side and short side. What packet is this? It's the same one as yesterday. This is what we worked on yesterday with trapezoids. The page right behind it was just examples I chose not to do. And then it is the midsegment one. You can't find this. If you had yesterday's, it should be stapled in that packet. It's still trapezoid, so yeah, it's going to be yesterday's. I think this was the front page right here. Non-isosceles trapezoids. So, I don't think the system I'm doing is too complicated, is it? But all right, let's. It says use the trapezoid above for question 1 through 4. So the letters are associated with this diagram that we see right here. So I am going to kind of go back and forth, which means I am going to write in the values, but I'm just going to quickly erase them because we're going to use those values for 1, 2, 3, and 4. So just be mindful of that, especially if you're kind of writing these down in pen. You may not want to kind of write them down in the diagram unless you want to copy the diagram down for each example. That's up to you. But let's take a look at this first one. It says if AB is 14, which is the one up here, and DC is 26. So I'm just kind of aware of the fact that I got the short segment, the long segment. The calculation's very simple. Add those two legs together, divide by 2. That's it. So it is EF is equal to 14 plus 26 divided by 2. Which we get, I think that's 40 over 2, which is 20. Always just double check the math behind this. It has to be bigger than the smaller segment and smaller than the other one. It should be right in the middle too, which is it's 6 units away from each of them. So this is making sense. Which is probably the easiest case scenario is just to find it directly, which is exactly what number 2 is. So I'm going to skip that one. If it were a class, I'd probably have you do that one on your own. But I'm going to jump right to number 3, and we'll do 3 and 4, because these are where it gets slightly more complicated, because instead they give you the midsegment, which is EF. So I'm going to label that in my diagram. EF is 22, and DC is 38. Find AB. So we can just directly use the formula, and we've kind of done strategies like this, especially really early in the year, when we thought about midpoint. The same strategy actually would work. If I think about how many units, what's the length of units it would take to go from 38 to 22? Well, I went down, what did I go down, 16? That means you'd have to go down another 16 to get to this line right here. almost identical to the midpoint. The calculation is going to show that. So if we went down another 16, I think we would get 6. We're going to kind of check to see if that is the case. That's one thing we can do if you're given the mid-segment. Just like if you were given a midpoint, and you, I think those are common questions on the weeklies. They gave you the midpoint and an endpoint, and they asked you, what is the other endpoint? And this is the strategy we basically did. We did it with the x-coordinate. We did it with the y-coordinate. We can do the same thing with the mid-segment to a trapezoid. If we do the calculation, it would look something like this. 22 is equal to 38 plus AB over 2. And in order to solve this, your best bet is to just cross multiply. When you cross multiply, you get 44 is equal to 38 plus AB. And then subtract 38 from both sides, and we get exactly what we did from the diagram above. We're going to get 6. So number 4, we can do the same thing because they give us EF again. And you can use the same strategy, whichever one you find more comfortable. If you like the algebra, go for that. If you like using the diagram, go with that. Whichever one you feel most comfortable with. I'm just moving that so I can erase it. So number 4, AB is 41. EF is 47. Find DC. And these numbers, actually, I think these numbers are even easier to work with than the previous one. If you're doing either strategy, 41 to go to 47, you go up 6 units of length. So the bigger one has to be another 6 units above. So whether you're doing the algebra or this, you should get 53. If you're plugging into the formula, it would just look like this. 47 equals 41 plus DC over 2. Throw it over 1, cross multiply, and we're going to get, we should get exactly that. I think it's 94 equals 41 plus DC, and we do. We get exactly 53. So those are your kind of 2 methods to figure out the mid-segment to the trapezoid. It's something we've kind of seen before. It follows the same principle. But that's about it. It's slightly different than the mid-segment of a triangle. The mid-segment to a triangle was just a 2-to-1 ratio. This one just follows kind of the midpoint rules. We can do the same thing with the algebra one, so we'll take a look at some of those. Maybe we'll do 2 of these, and then we'll jump into that proof. So it says for trapezoid PQRS, Y and Z are midpoints of legs of the legs. Find Y, Z. So the fact that they're telling you that they're midpoints, Y and Z, and the fact that they're connected tells me that they are indeed it is a mid-segment because the midpoints are connected. Now here's a case where using your rules is not going to be too helpful because the only number they give you is 38. You can't figure out, well, how many units does it take to get from here to here because you don't know it. And you also can't figure out how many to go from here to here because, again, you don't know it. They are algebraic expressions. So this is a case where you are going to have to rely on the rule, and then the algebra will help us figure out the value of x, and then we can plug in to figure out anything we want afterwards. But this is going to be the rule we're going to have to use for number 5. So we'll just plug in. It starts off with the mid-segment. 5x minus 19 is equal to I'm on 2 different problems. Oh, I just underlined the midpoints here. You're right. It's the same wording, but so 5x minus 19 is equal to the big leg and the short leg. Doesn't matter which one comes first because it is addition, it's not subtraction, so it's not going to matter. 38 plus x plus 14, all divided by 2. What's your question, Julia? Why are you typing that? I'm going to continue with this problem. I'm going to combine like terms in the top. Also going to put this over 1. Combining like terms, we get 52 plus x. Now I'm going to do my cross multiplication. Make sure when you cross multiply, especially right here, you distribute that 2. So it's 10x minus 38 is equal to 52 plus x. Even over the internet, you are a distraction. Now, I'm going to add 38 to both sides and subtract that x from both sides. Subtract x. We get 9x equals, I think we just get 90 here. Divide by 9, we get x is equal to 10. We are not done there because the question does say find yz. Always double check that. So when I'm plugging into yz, that is the midsegment. It is the 5x minus 19. So yz is equal to 5 times 10 minus 19, which is 50 minus 19, which is 31. All right, we'll just do one more. They're all kind of along the same lines, so we'll just go right to number 6. Same idea. They give you that L and M are midpoints, therefore LM is a midsegment, so we can add the two the bases, G, H, and KJ, add the two bases, divide by 2, set it equal to, in this case, 25. So it's going to be 25 is equal to the two bases, 2x plus 11 plus 6x minus 1 all over 2. I'm going to combine like terms. I'm also going to put this 25 over 1. Combining like terms in that numerator on the right-hand side, 2x plus 8x. That becomes 8x. 11 and minus 1 becomes plus 10 over 2. So from here you can cross multiply. You could also reduce these things by 2. So you could distribute that way. I'm not going to do that because we typically don't do that. But I'm just going to do this. And in this case, we don't have to distribute. So this algebra is arguably easier than the previous one. So it's 50 equals 8x plus 10. Subtract 10 from both sides. You get 40 equals 8x, and x is equal to 5. Find kj. That is the question. Don't ignore that. So let's just take a look. Kj is right here. We are plugging in for 6x minus 1. So kj is equal to 6 times 5 minus 1. So it's 30 minus 1, so we get 29 for our final answer. So I'll zoom out so you can see the entire page. So everything we've done so far. Oh, it looks like we're back up to 16 people, which is better than the beginning. So that's good. Pretty straightforward. If there's any questions, just type them in chat. Otherwise, I'm going to put up what we're going to be working on next. I did say at the beginning of the stream that the thing we're going to work on right now, you do not have in your packet. We're just going to do it on graph paper. Luckily, there isn't any really writing that's going to be heavily involved. So this is actually, I just took this right from the old Regents. Just have an old Regents right here. I believe it was this question right here. It did take over the space of 2 pages. So I'm going to flip back and forth. I'm going to read them. And then there's a graph. I would just put these on graph paper. You don't need to write down the question unless you want to. That's completely up to you. But we're going to kind of see how these questions are. So it is a single question that spans over 2 pages. That's not uncommon. This has happened plenty of times before. But there isn't a ton of information that we need. So just reading off, this was a 4-point question, by the way. I think it was a very fair one, relatively easy. And I'll kind of tell us kind of some of the hurdles that we have to kind of figure out beforehand. It says Riley plotted ABCD to form a quadrilateral. We need to prove that Riley's quadrilateral, ABCD, is a trapezoid. So that's almost identical. I would do it on graph paper. I mean, really the only thing you need is those 4 things written down. And then just knowing what we are going to do. That's really all you need. This entire question is not a ton of writing. And then we're just going to prove it's a trapezoid. That's the first part of the question. Before I really jump into doing that, I'm just going to kind of discuss the thought process behind how I'm going to do that. But I'm going to give you a second. Get those points written down, especially if you are going to follow along and do these on graph. Just make sure you have them written down, then you can graph them on your own. But that's the first part of the question. So you have A is -1, 6, 3, 8, C is 6, -1, and D is 1, 0. If you're thinking about how we're going to prove it's a trapezoid, and you think about the definition we wrote down for a trapezoid, it is a quadrilateral with one and only one sides that are parallel. This proof does force us to use slope, which is fine. We've used slope for almost every other proof up to this point, so we should be used to this. Find 2 slopes are the same, and then find the other 2 are different. And we've proved it's a trapezoid. The second part is where it gets a little bit more interesting. It says Riley defines an isosceles trapezoid as a trapezoid with congruent diagonals. Use this definition to prove that it is not an isosceles trapezoid. So because the definition that Riley is providing is congruent diagonals, this does require us to use the distance formula. We don't have a choice here because the basis of the question is saying, well, this is what makes a trapezoid isosceles. There are other things that make a trapezoid isosceles. It could be the legs that are congruent, but because they're using this definition, we need to use distance only for those diagonals. And we're going to prove that it is not an isosceles trapezoid. So we got to make sure when we do distance, we get two different values. And I did mention that last week that getting a proof where you have to prove that something is not something is relatively common. If I go back to the other page, it does say the use of the set of axes on the next page is optional. They say this for every single coordinate geometry proof. I'm going to tell you right now that don't treat this as optional. Even though it is, you can get full credit. It is far easier to visualize and have your expectations set on knowing what sides are parallel, what sides are not, what do the diagonals look like, and then you can have all the letters out right there. So now I'm going to graph my trapezoid. -1, 6. I think that was A. 3, 8. Um, 6, -1. And lastly, D, 1, 0. So just by inspection, it definitely looks like a trapezoid. And just notice where the legs are, the bases are, which pieces are parallel, which pieces are not. So it looks like these are our pair of parallel sides, which are going to make it a trapezoid. These are our non-parallel parts right here. So everything's looking good. And because these legs, they look different in length. DC looks slightly longer, I think. It definitely tells me that this is not an isosceles trapezoid. But I am going to draw in those diagonals because I know I'm going to use them later, at least for the second part of the proof. So I am going to jump into the first part of the proof, which says, in general, prove it's a trapezoid. So the easiest way we're going to prove it's a trapezoid, we're going to show that these two sides, AD and BC, are parallel. So I'm going to do them first. And this is why I like graphing them. I know to use AD first, then BC, or vice versa. Then I'm going to show that AB and DC are not parallel. And then we're going to make our statement for our formal proof. So going back, we're going to do the slope to AB. Actually, do I have that right? AB? Oh, nope. AB is the green one. I want to do AD. So I'm going to do the slope to AD, which my points are right up there. 0 minus -1 over. Oh, that's wrong. I mixed an x and a y coordinate. 0 minus 6. Just double checking that looks better. Yep. Now it's 1 minus -1, which is equal to -6, this becomes addition, it's 2, which is -3. And again, you have it graphed. And we mentioned before, you don't need to show this work, especially if you have it graphed. You could just do your rise over run. It is going down 3 over 1, down 3 over 1. So that looks good. Now I'm going to do the slope to BC, which we are hoping to get exactly the same thing. So the slope to BC is -1 minus 8 over 6 minus 3, which is -9 over 3, which again is -3. So they are both going to reduce. Make sure that's why you reduce, because we do get different values right here. You can bracket this off and put parallel. But now I want to check the other two sides, and I want to show that they are not parallel. The reason we need to show this is because if they were parallel, we would have to classify it as a parallelogram. So basically we're showing that it's not a parallelogram by showing that they are not going to be parallel to each other. Because if they were parallel, you'd have opposite sides parallel. That's a parallelogram. That's why I need to show this. You can't just show the one pair of sides and then just jump to the conclusion and say it is a trapezoid. Because trapezoid and parallelograms are different types of quadrilaterals. That is why we're going to need to show the slope of, so now I can do AB and DC. So these are my green ones in my diagram. AB and DC I'm going to be finding the slope of. So the slope to AB is 8 minus 6 over 3 minus negative 1. We get addition down here, 2 over 4. Which simplifies to 1 over 2. And then we're going to do the same thing with CD. But now, unlike all our proofs we've done up to this point, we're not expecting the same value, or we want kind of anything other than 1/2 to ensure that we're going to get a trapezoid. Again, you can look at the rise over run. I'm just going to do it this way. 0 minus negative 1 over 1 minus 6. 1 minus 6. So I get plus 1 in the top, negative 5 in the bottom. I'm going to bracket these off. But I'm not going to be put in parallel. Instead, I'm going to put not parallel. But I'm not done there, not for the first part, because it is a coordinate geometry proof. It does tell me to prove it. We have pretty much 90% of the work already down. You have the math to justify it, but we do need that explanation. So in this case, this is an explanation we've never written before because we've never proven a trapezoid. So I'm going to say that quadrilateral ABCD is a trapezoid since only one pair of sides are parallel. So typically we've always been writing opposite sides are parallel, but we don't have both pairs of opposite sides. We only have one pair of opposite sides, which is exactly what a trapezoid is. So that kind of concludes the first part to the proof. And it works just like any other proof. I knew this question threw people off because it was a trapezoid, not a typical parallelogram, but it works just the same way. Now I'm going to do the second part of the proof, which says we are going to prove that it is not an isosceles trapezoid, but we are forced to show that the diagonals in this case are not congruent. That's going to be the only way we're going to prove it. So we are forced to use distance even though we've just used the slope. And I think that's why I kind of like this question. It does force you to use both equations. You had to use slope for the first part and you have to use distance for this part. Just make sure you're going to do the distance to the correct two, which in this case is going to be AC and DB. This is also the benefit of drawing it out. You don't have to look at the letters and figure out which two letters are the diagonals. It's right there in the diagram when you draw it out. We're going to be finding the slope to these two lines right here. So AC, so I'm going to do the distance to AC. So AC is, I'm just going to write it the coordinates, negative 1, 6 for A. C is 6, negative 1. So we're going to do the square root of 6 minus negative 1 plus negative 1 minus 6, pretty much the same thing. So this works out pretty easily. You get 49 and 49 under both of them, because one is positive 7, the other is negative 7, because that becomes addition. So you just get the square root of 98. You're not required to put this in simplest radical form or anything like that. I'm not sure if 98 can be broken down. I don't think it's divisible by 4, so I don't know what number it would be divisible by. Oh, I guess 49, right? It'd be 7 square root of 2. But you don't need to do that. I'm just going to leave it as a square root of 98. Now I'm going to do the slope to the other diagonal, which is BD. Just going to write out the coordinates to BD. B, I think, was 3, 8, and D is 1, 0. And remember what you're trying to get here. You're trying to prove it's not isosceles, so you do not want to get the square root of 98. Don't force it so you get the square root of 98. You want to make sure you get anything but that. And that's also what makes this maybe slightly more challenging, is you have no real expectation of what it's going to be. Just by looking at it, I would guess it is shorter, so it should be smaller than the square root of 98. But that's really the only assumption I can make about this line segment before I do the calculation. So it's going to be the square root of 3 minus 2, sorry, 3 minus 1, which will be 2, plus 8 minus 0. So this becomes 2 squared, which is 4. This becomes 8 squared, which is 64. So kind of as we predicted, it is smaller. It is the square root of 68. So I can bracket these off and write not congruent. But because this is a question that does use this word prove, make sure we write a statement to justify the mathematics that we have just done, which is going to be ABCD is not an isosceles trapezoid since diagonals are not congruent. So that was a 4-point question on last year's Regents, just to give you a sense on some of the kind of questions they could ask. And like I said, we practiced the coordinate geometry stuff. They just threw in a slight curveball with this one by just wording it slightly differently. But you have the tools necessary for you to solve any problem like this. They could ask it with any geometric figure we've ever covered in class. They could, I've seen it with triangles. Prove it's isosceles but not equilateral and stuff like that. Those are typically easier, but that was rough, was it? Or was that supposed to be a question mark? I don't think it's too rough. I'm not sure though. I can't see you guys, so I don't know how to gauge your reaction on the difficulty of these kinds of proofs. I like them better, honestly, but everyone's different. It was harder than the other one we did. Okay, that's fair. That is probably going to conclude what we have for today because we only have 2 minutes left. So yeah, we'll end it right there. Tomorrow, I want to practice kind of classifying some of our quadrilaterals. So that is what we will do. Good luck for anyone who has that global test. Hopefully it goes well and your remote learning is proving to be successful. I thank you all for coming here. Like usual, direct anyone to the YouTube channel or the stream so they could watch the videos over so they know what they're doing, because there's at least, I'd say, 8 of your classmates who are not tuning in on a regular basis. So if you know who those classmates are, just help them, direct them in the right direction. All right? I'll see you guys tomorrow.